Okay, moving on to 1c. So the cubic y equals to kx cubed minus k plus 1x squared plus 2 minus k of x minus k has a turning point as a minimum when x equals to 1 precisely for what ranges of k. Okay, cool. So, turning points, right? First thing in your head, differentiation, right? So let's differentiate that thing, okay? So it's not the hardest thing to differentiate because it's just normal polynomial. So let's try that. So 3k x squared. Okay, I should write y prime here, right? So minus 2 times k plus 1 times x plus 2 minus k. Okay, and we're saying that, okay, when x equals to 1, what sort of thing happens? So 3k minus 2k minus 2. Okay, I've expanded it, okay? So just to let you know, plus 2 minus k. Okay, so when x equals to 1, the thing is that all these things cancel out nicely for some reason. So whatever values of k it is, okay, whatever value of k, is put into the polynomial, x equals to 1, there will be a turning point there. Okay, but, it's not a guarantee that it's a minimum. Okay, so how do we check that as a minimum? How do we check something as a minimum? Well, we do the second derivative, right? And it has to be greater than 0, right? So remember, minimum is greater than 0, okay? It's quite tricky, right? It's quite counterintuitive, how minimum is actually greater than 0. Okay, so y double prime, what is y double prime? So let's differentiate 2 times. So it becomes 6kx minus 2 lots of k plus 1. And that has to be greater than 0. Okay, so we're just solving that, right? And x is 1, remember, x is 1. So this becomes 6k minus 2k minus 2 is greater than 0. So 4k minus 2 greater than 0. So k is greater than 1/2. Hooray. Okay, so k is greater than 1/2, and that's one of the answers. So I'm pretty confident that we got it. Okay, so answer C. Cool. Okay, so it's quite nice. It's quite nice how x equals to 1 is always a turning point for the polynomial with some parameter k. And yeah, remember to check the second derivative. Yeah, don't answer all values of k. If you answer all values of k, you're trapped. Okay, so remember that minimum second derivative is greater than 0. Cool.